is about 700 bytes. For the real image, the size is 2 kilobyte. Welcome to another video of machine learning series. This time I want to talk about the usage of autoencoder for image compression. First, what is compression? Compression is an act to reduce the size of the file while keeping the content same or at least looks same. It's essential for a binary file like a piece of software or document to be lossless, right? When compressed, because just one bit wrong in the binary code can make the entire file corrupted. It's different with image, where a slight change in the image quality will not be noticed by the human eye in most cases. I mean, look at the JPEG file. Okay, now let's move on to the neural network. So basically, the idea is to encode the image matrix to a vector. This vector is a representation of the information of the image. Let's do an analogy. When you look at this picture, this image is very easy to remember, right? You don't care about the resolution of this image because you don't need to remember every pixel of the picture. Whatever the resolution is, the effort to save the information about this image to your brain is the same. And if I ask you to draw the same picture based on the information saved in your brain, you can draw a similar picture easily. Now we use this concept in neural network. In neural network, there is an architecture called autoencoder. Autoencoder is consists of an encoder and decoder. An encoder is part where we save the information based on the image matrix in the form of vector value. Please don't misunderstand this vector with vector image like SVG or SHP. No, we talk about literally a math vector, a one-dimensional group of numbers. This encoder stuff can work because, layer by layer of neural network can form an abstraction understanding of the layer beneath it. And the decoder part is where the neural network redraw that image based on that vector. Okay, that's all for the theory. Let's move on for the hands-on part. Okay, here I train the model in the Google Colab. This is the code, and as you can see here, this is the class for the autoencoder model. Here we have the encoder and decoder. For the encoder, you see here, I compress the data from the original input to the here compress total, which is compress total is here. It's just a vector with size 10. And then after that, the decoder part is to restore from the vector of 10 to the original image here. And here, this is the loss function, and here is for the load the image. And the image I'm using for this experiment is GFAR10 dataset. This GFAR10 dataset is just a low resolution image. As you can see here, the resolution is just 32 times 32 times 3. 3 here is the RGB dimension, and 32 times 32 is the width and height of the image. Why I'm using this low resolution image? Because the low resolution image will make my training process will be faster. And here I just want to show you the concept of this idea. And here, this is the training part. Here, after I train that, I save the model here. Yeah, for the model, I name it model.pth. I already download the model in my computer. Now let's move on to my computer. And this is the code. In here, I'm using the same class and the same size of the image and the same size of the vector. And the point of this code is to compress the image. Here, I take the encode part of the model output and I save that in this compression file directory. Okay, let's just run this code. Okay, here let's run. And the result will be first here. This is the real image that we using from GFAR10 dataset. As you can see, the image is quite low resolution. And then for the vector, I save it in compression file here. So see here, this is all the torch vector that we compress. So this is the compression file. As you can see, the compression file size is about 700 bytes. But for the real image, the size is 2 kilobyte. And yeah, we success to compress the file. But what if we want to restore the image from the compression file? This is the code for the compression image. And here I'm using the decoder part. And then after that, I save the restored image in the folder of compression res. Okay, let's run the code. Okay, done. Let's see. Compression res. And here, look. This is the restored image from the vector. Let's see, for example, this 97 image looks like this, the image of cat, and the result for the restored image is, let's see, 97. The silhouette in general is right. As you can see, this is just a blob of white in the restored image, but in the real image it's actually a cat. But as you can see, the dominant color in this cat is white. This is the blob of color in here is wrong, right? Actually it's just a black color. Summary is, in the restored image we can just capture the silhouette. This is because the nature of the neural network algorithm. And that's it. And I think that's all. Thank you for watching. Bye.